All right, we skipped a day of filming, and I'm super excited to see what these two guys are up to. I'm always intrigued by the way that the houses are built, especially at the framing stage when you get to see how the members are placed and why they're placed in that manner. So have a look at all the point loads that we were talking about in other videos. Look at that, a beam sitting right over top of that. It stretches on the other side, where it's picked up by another point load. And look at that, there's a beam that's attached to this beam with a hanger, and it stretches all the way across the front to another point load. And that is attached to another set of beams that stretch across both sides of the house. So everything interacts each other structurally. It's kind of neat because you get to follow how everything interacts with each other, and it all ends down to the foundation where it holds the entire house together. And how all these components are held together, check it out. Hangers, special nails that are fastened into the beams, tie downs. We'll walk over to an area later on, we'll show you some tie downs. Shear walls around the staircase, we'll talk about those. Check inside there. Examples of two tie downs, Simpson tie downs. All these components form part of an overall system which holds the house down and stops it from shifting and moving in certain directions. So these are all very important things to look at, and this is where I get really excited because I can see it all come together. And if you look at the outside of the house, the straps that are extending beyond that rim board, those also form part of the system where it holds the sheathing, transfers the holding strength from floor to floor. So we'll get into that later on, but right now you see everything's coming together and how each component is ready for the next. Right off the bat, I know there's a toilet upstairs in the master, and I see that the framers had put an arrow there. They're conscious to leave space for a floor flange to be installed so it doesn't bump into their TGI. So it's good on the framers. But now the tricky part is to find out how to get the piping to flow to the lower floor. So as we progress through the framing stage, we keep notes on these kind of things. And once the plumbers come on site, that's when we start to lay it out together. If you check it out, there is really nowhere for any pipes to run. So that's for the next steps to come. In the meantime, let's talk about windows. When it comes to ordering windows, it's always easiest to throw the set of plans to the window supplier and let them determine everything. What you don't want to happen is have a surprise when the windows get delivered. So we communicate the window openings very carefully with the framer ahead of time so that everybody's on the same page. Now, for example, we have a 2'6" by 8 foot tall window here. What I typically would do is give the framers the instructions to frame it exactly 2'6" wide by 8 foot tall. I'll tell the window company to subtract a ½ inch from that overall size so that when the window comes, you have a 1/4 inch of play for any kind of plumb or level issues. And you also leave enough space for rod and caulk on the sides. So you can actually order the windows way in advance just based on this, but you have to make sure that along the way, if you spot anything, to make those corrections ASAP, because when windows get into production stage, it's hard to recall it. So for this house, everything's a flange window system, meaning that the windows will have a flange overlapping the outside sheathing. On the basement, if you remember, we have concrete openings, and those would be a flangeless type, where you mount the windows side mounted into the concrete. So for this one, we have the windows already ordered. As we frame level to level, we double check all the measurements to make sure everything's right. So far, so good. And it's good that the window supplier would also give us a copy of the original drawings with their own markings on it, indicating the rough openings so that everybody's on the same page. Let's talk about door openings. Now, typically when it comes to door openings, an easy way to calculate it is whatever size of the door plus 2 inches in width and approximately 2 inches in height. Some people like a little bit less, but generally that's an easy way to calculate it. So you have a 4 foot wide door, you allow 2 inches more for the rough opening, and that's to accommodate the thickness of the jamb on both sides, plus a little bit of room for shims and insulation during the install. For the height, same thing. You also got to allow that 2 inches for a casing to cover, or if you don't use casings, but in the event you do casings, it covers the jamb, 1/4 inches from the jamb, overlapping the framing and overlapping the drywall. A lot of houses nowadays, they order these multi-panel folding door systems or big wide sliders, In this case, we have a triple pane, triple unit slider that will slide right across this entire back of the house. So check out this beam that's put right across to allow for that opening. Now, for something like this, I would not normally add my own rough opening sizes or allowances. I would have the specialty glass or frame company to come and do their own measurements, communicate the needs of the frame directly to us, and we'll provide the frame opening. In this case, we have not given the final height yet. Once the measurements are given to us, we'll frame it in place just to eliminate some of the mistakes that could happen if you frame it ahead of time. So better leave it open. And you see that extra piece of plywood that's hanging down? That's for any kind of height adjustments that we can make later. Once we have all the framing in place, just trim it off and your opening is done. You can also imagine for something this wide, the frame running this entire width of the building will have a tendency of sagging. For the doors that are going to be attached to that frame, they form a very heavy component of this whole system. So you have to always remember that the fastening of that frame will have to be directly to that beam, not to any intermediaries, because the beam has a lot more strength than any intermediary lumber that's going to be put in place. So when it comes to installation, we're going to have them install it so that they can ensure that they're fastening to the right spots and they know what fastening points to use. And it'll give us a bit more reassurance that the frames will not have that much tendency to sag in the future. Although houses do shrink over time, houses do settle, they will allow a little bit of a deflection in that frame to accommodate that movement. One other component of the structural is the shear wall. In this case, we have a shear wall around the stair area. And what shear walls do is limits the kind of movement, sideways movement that the house would have in the event of seismic activities. But look at how it is done. Shear walls are lined with plywood along the entire face of the areas where the openings occur. So in this case, the stairway will have shears on both sides to help with any kind of moment movements in the frame of the house. And this will be carried from the basement right to the top. So when you do have a shear wall, just take into account that the spacing required for your utilities or any kind of rough-ins, because these walls usually packed full of lumber and point loads, and they're a lot more sensitive to cutting than anything else. Although this wall runs from top to bottom, it's not always going to be empty for you to run your utilities. It's always a lot better to have an extra cavity wall or a chase wall installed beside it so you can run all your runs straight from the roof right to the basement without having to zigzag through all the members within the shear wall. Look at these hold downs. So earlier episodes show SSTB rods that were implanted inside the concrete, and you saw them sticking out quite a ways earlier. Well, this extended up to the main floor, and this is how it's tied on to the post on the corner of the house. This is a Simpson strong tie anchor. What it does is it extends the holding strength from the foundation through this floor, fastened to the columns, which carry to the next floor. And it's going to be continuous throughout the upper floors as well. This is another example of another hold down. Note the nailing pattern of this 2x6, very heavily nailed. There's actually a spec that tells us the nailing pattern from the structural engineering plans. Have you ever wondered how overhangs are created in framing? Have a look at this. So I'm standing underneath a future overhang here. This consists of about a 4-foot area that'll be eventually sheathed over and providing some kind of shade in this area. But have you ever wondered how that's framed? Let's have a look. You have about approximately 4 feet overhanging the outside, and that extends to the inside of the house by about 8 feet on the same member. It creates an area where the upper level above this floor can sit on this beam, creating a holding it in place to allow this part to stretch out. And you see that other cross beam that goes right across the back? Well, that's picked up by the exact same cantilevering beam on this side. And this is also reaching into the house, but this one a little bit further. So this way, it gives you a very stable, kind of like 2 arms sticking out like this, that can create that overhang effect. Eventually, this will be sheathed over, and that's going to form part of the upstairs roof deck. Another component of the structural system is the blocking. Not as obvious as the metal components, but these actually do play a very important role. Blocking is just simply 2x4 or 2x6s. They're put where the sheathing joints exist. So where the sheathing joints come together, there's always a 3/4 inch or a 1/2 inch gap. Blocking goes behind it and gets nailed from the outside, kind of stiffening the entire wall system. Well, from the outside, it's a bit more obvious. This is where the two pieces of sheathing meet, and you can see right behind her, it's all solidly blocked. Now, when it comes to another component of, let's say, air tightness, this does help with stopping airflow to the outside, and we'll get into that later. But closing off a 1/2 inch or 3/4 inch gap every couple of feet over 3 floors significantly reduces the air leakages. And what we can do on top of this is we can actually tool some sealant over top and around it to create an even more airtight effect. However, some of the gaps are a little bit small and we may not catch them all, and that's where something called air barrier will come in. Last thing I want to mention about structural is when it comes to the outside plywood, you have to really look at the nailing patterns, okay? So you remember we have the point loads that carry itself from the top all the way down to the foundation. Well, this only is useful if you have the plywood nailed properly. Like, look at this. This is completely all gang nailed together. That means there's a lot more nails here, a lot more concentration of nails than, for example, along a regular stud. Okay? There's a spacing requirement for nailing along the standard studs, but when it comes to the point loads and the corners, check it out, way more nails. So these are all pretty general, but they're specified on the first page of the structural plans. Always remember that. These are the lines for the blocking. We talked about the blocking earlier. Okay? So the more nails that you put in here, the stronger it is. And check out this is where a major point load is. Okay? So lots of nails along here. Engineers will come look for this stuff when it comes to their turn to inspect the house. Let's get out of here. Let these guys get back to work. I want to check it out tomorrow. I want to see this entire thing covered with the rest of the TGIs. I'm excited to see the ceiling heights. I'm excited to see how this floor plate takes shape, and you can start identifying where the kitchen components are going to be and where each bedroom and each washroom is going to be located, and the house is going to take shape.